welcome to this third demo session from the DiSSCo development team at Naturalis. We aim to give this demo sessions regularly to give an update on what the development team is doing in line of agile development. Normally, we would like to do that after every sprint we do. But since it is a small team with only 3 developers, we aim to do this bi-monthly. So this is the third session, and recordings of the earlier sessions are available in our DiSSCo blog. I think I can give the floor to Sam. So this is the agenda. As before, we will introduce what is new since the last time we had a demo session, and we also look forward a bit with what we are planning to do next. And we hope that there is some room for discussion as well. We try to disseminate this regular event a bit more, and I'm happy to see that we have much more participants this time. So apparently that works. So yeah, I welcome everybody here. I have to say that this is a technical session, so the updates will be a bit technical. I hope you can understand that. And we also aim in these sessions to demonstrate some things that we are doing. In particular, in this session, we want to demonstrate the patch annotation services. Sam is our lead developer, so I will now give the floor to Sam to give an update.
You can hear me, right?
Yeah.
Yeah. Okay. Yeah. Let's move forward. Yeah. As we got a lot of new people in here. Oh yeah. I think you went over the aim. So the aim is we're working on the Deliverable 3.1, which is a minimal viable product of the DiSSCo core infrastructure. Now we'll get back to this. What's the core infrastructure is. We will touch a bit upon other projects. I don't think we'll do that much in this session, but we're working on other projects as well on Tetris and maintaining some bicycle stuff. Yeah, so we're looking at what we've done towards, let's say, the next 2 months, where we have a lot of holidays in the next 2 months, so we'll be a bit less what we can do, but we'll look forward on what the next step is, and see if we are still aligned with any other work packages. So other work packages can also give feedback on what we're doing. So we see DiSSCo mainly as a platform, and especially the core infrastructure as a platform. So the core infrastructure here is the blue part in the middle, and on the left side we have data providers. Data providers can be a collection management system or a digitalization suite, or somewhere where specimen data is housed. We will, on the right side here is then the data consumers. So those are consuming data from DiSSCo. So this could be data aggregators, but could also be a collection management system, as we supply data back to the collection management system. And then, yeah, working on the DiSSCo core infrastructure can be human agents through something called Discover. We'll shortly show it in this demo as well, but we have other demos where we show a bit more of the Discover platform. It could also be Elvis or collection description dashboards or citizen science platforms where human interact with the specimen data. And we also have machine agents working on the specimen data. So we have those 2 parts, and it's all being facilitated by this DiSSCo core infrastructure. And that core infrastructure will collect and harmonize the data into our open digital specimen. And part of our work the last 2 months has been on further developing this open digital specimen. We'll start minting PIDs. We have done some work as well on that part. Reversion data, we'll ensure that you can annotate data, extend data. We'll give a small demo of how we can extend and link to the bot.eu infrastructure, which is being developed within the Biodiversity Genomics Europe program. And this part falls behind and we expose data.
Yeah, muted, Sam.
Oh yeah, that helps. Yeah, sorry. I was trying to put all my buttons in the corner. Yeah, and we expose data to APIs so that other infrastructures can work as well with the data. Yeah, and so this is the part where our main focus is in getting those machine annotation services ready. We have this Discover platform which we are developing, which already functions on top of the APIs that the DiSSCo core infrastructure provide, and all the parts that the DiSSCo core infrastructure needs to provide to the other services. So we'll start with a recording. For some reason, each time we give this demo, or other developers are either getting their tooth pulled or are on holiday or something else. So Sue Len, one of our developers, has been working a lot on batch annotations. It's been on the board for a couple of demos already, because it was quite tricky to get it right. We now have something which functions for the batch annotations for the machine annotation services. So the machine annotation services are these machines working on the data. And she has recorded the demo for us. Then we'll look at some of the changes in the data models and go over the rest. But let's start with the demo of the batch annotation services.
Hey, hi everyone. My name is Sue Len. I'm a developer for DiSSCo, and today I'm going to talk about machine annotation services and how by getting them to do less work, we got a lot more out of them. So why do we want to annotate specimens, and why do we want machines to do it? Well, unfortunately, there's no such thing as error-free data curation, especially in the biodiversity field. As taxonomies change, specimen data can become outdated, and as new pipelines and methods are developed, you have more options to enrich your data. So the Discover platform of DiSSCo offers a space for community experts to annotate specimen data like this post-publication data curation. And experts can suggest additions or corrections to data within DiSSCo, but we also offer a platform for machines to do the same. These machine annotation services, or MASs, are services that are deployed independently from DiSSCo and ideally developed independently from DiSSCo as well. We have some demos available on our GitHub that you should have access to. And these demos, we have one that links to other infrastructures, we have one that georeferences, we have one that uses machine learning to identify plant organs, but really the possibilities are endless. I'm really, really excited about them. So how do they work? If a user wants to use a machine annotation service to annotate a specimen, they would create a request through Discover, they would schedule a job, and that request would get sent to the MAS. And the MAS would look at the digital specimen, and maybe it's a georeferencing service. So we'd look at the locality information and derive that georeference information and return an annotation with the coordinates, for example. And then that annotation is associated with the specimen, but it is a separate object. So you do that once and it's great, you have an annotation with the coordinates. But what if this one beetle, it was part of an expedition, and you actually have several beetles with the exact same locality information, and you want them all with coordinates? So you go and you schedule this several times for each of these specimens in your expedition. And maybe also there's several specimens within DiSSCo that all have the same locality information as well. All of a sudden, you're doing a lot more work scheduling all of these jobs, and the MAS is getting overwhelmed. A lot of these services are community-based services with very limited resources, and it's giving you the same result every single time based on the same information. So that's a waste of your time. It's also a waste of the MAS's time and the community developer who made this service. And if there's one good way to get blocked by one of these services, it's spamming with repeat calls with the same information, which I would know. So because these MASs are developed independently from DiSSCo, we don't know necessarily how the MASs are developing their annotations, how they are producing that information. But what we've done is we've given them an opportunity to let us know. So this is our regular pipeline. This part hasn't changed. An annotation event is sent by the MAS, and it is sent to the annotation processing service of DiSSCo, and it is picked up through a Kafka listener. And a Kafka listener is just an asynchronous process that listens for messages. When an event reaches the listener, it gets processed, and then it is written to the database. So this part hasn't changed, but now the mass can also send us batch metadata. So this is the mass saying, this is the information used to derive the annotation in this event. So the first part of the pipeline doesn't change. The Kafka listener catches the message, it's processed and written to the database. And then if batch metadata is provided, this information is used to construct queries through Elasticsearch. And all of our specimens are already indexed through Elasticsearch. So we're able to, with this batch metadata, pull out all of the specimen within DiSSCo that meet the criteria of this batch metadata. And then we take those search results and we apply the annotation, the parent annotation from the event to all of those search results. And then we take that and we build a new annotation event, or we build several annotation events depending on the number of search results. And then we send those events asynchronously back through to the Kafka queue to be picked up by the annotation service. So we don't process all of the search result annotations right away because we don't know how many we would get. And the annotation processing service works best in batches about 200 to 300. But instead, the information is sent back to the Kafka listener without the batch metadata so that we don't get an infinite loop. And then the annotations are processed and written to the database. And all of a sudden, with a single job, you're able to get thousands of annotations, everything that this mass would have produced if you had run it individually on all of these specimens. So it's it's not necessarily very complicated, but it's a very good way to get a lot of annotations really quickly. There are some limitations with this approach, of course. It must always produce the same output given the same inputs. So machine learning based approaches and masses might not necessarily be the best candidate for this. It also can't be too specific. So if a mass relies on unique information, then there will only be one search result, only one specimen that meets those criteria. So there's no point in batching it. So that's why georeferencing is such a good use case. It uses a set list of parameters, locality information, to always return the same values, which are coordinates based on the locality. And because it's such a good use case, I'm going to show you how it works exactly. Okay, so I selected this digital specimen from DiSSCo. You can see here that it has origin information, so locality information, but no georeferencing, which means it'll be really useful to have an annotation with the potential coordinates. So in order to create a machine annotation service or to schedule one, you need to be logged in. You can see I'm logged in here. And so I'm going to go to Actions, Machine Annotation Services, and Schedule a New Service. To choose which mass to schedule, I'm going to pick the GeoPick OSM georeference tool. And I'm going to select Allow Batch Annotations. So we can see it's been committed successfully. This box here is querying the specimen, seeing any jobs that are scheduled or completed for the specimen, and it will update when it is ready. Discover has essentially sent a message now to the machine annotation service I just scheduled with the specimen information. The mass is going to take that specimen information, conduct its calculation on its coordinates, and send an event back over to the processing service, and then it'll go through that pipeline we just discussed. It might take a couple of minutes. That's just because we don't run services that we're not using. So before this mass can be conducted, can be utilized, it needs to be spun up first. The container needs to be spun up. So yeah, won't be too much longer. Yeah, you can see it's just been completed now. That's great. And because it's a little faster, we're going to go through the API. And we can see here's the JSON representation of the specimen. So here's the digital specimen, the original data, and here's the annotation that has been developed from this. So it's a number of coordinates that have been determined based on the locality information. So unfortunately, I don't have any way to show you in the front end what annotations were created as a result of this batch. So I'm going to show you in the database and through some APIs right now. That feature is upcoming. But now I'm going to take this annotation ID. I'm going to get all annotations. So we can see in the database here, Yeah, 64 annotations have been produced. Yeah, we can see the ID and the target ID, the value of the annotation. Let's pick a specimen we want to have a look at. Yeah, so this is the ID of another specimen. Also from Egmont. And if I go into view all annotations, yeah, we can see an annotation has been created here as well. So yeah, I would love to show you the 64 annotations that have been created, but I think you're gonna have to trust me. That has been batch annotations. And I hope that you've enjoyed this presentation, and I hope that Sam can answer any of your questions. Thanks.
Thanks, Sue. Yeah. So batch annotation, yeah, we're really excited about this feature. So with one click of a button, we can correct thousands, millions of specimens. If we see one data issue with one particular institution, we can say for that particular institution, we're going to correct this particular field for all their specimens. So the possibilities are endless. It was really tricky to implement, as we have there are a lot of corner cases, and if you do something wrong, we might end up with millions of false annotations, of wrong annotations. So there were a lot of corner cases, but we're really happy that we have now implemented this for the machine annotations, and we're at this moment working on implementing this for human annotations as well, so that in the front end you can let's see, yeah, you can actually also indicate.
Hi everyone, my name is.
Yeah, and there we are again. That you can actually indicate, I want this specimen to be. Here we are. This annotations that I'm now creating for this specimen, I also want to apply it to all annotations where certain values are present. So that if I want to do this georeference by hand, which I could very well do, creating the georeference by hand, that I can also say for all other specimens where the country is Netherlands and the locality is Egmont, add these annotations to all those specimens. So there's, I think, a really powerful tool in and step in the data creation. There will still be a lot of things we need to take care of, but yeah, it's getting there. It's getting there. Are there any questions regarding batch annotations? Okay, always feel free to reach out to us. If you have any questions or want more detailed background information on how we do things with using batch IDs and objects where we store all these things so that we can attach and detach things from the batch, yeah, feel free to ask more details if you would like. The second part of the presentation will mainly go on to the data model on the OpenDS. So a while back we started with this schemas.disco.tech, which is a place where we store all our JSON schemas. So for the internal storage, we use the JavaScript object notation, the JSON, and to define schemas such as a digital specimen, we have all these schemas on which we generate our code, but which we also can use for the APIs. So these are large schemas on which we have basically an object, in this case a digital specimen, and the object we indicated is that these have properties, and these have a type and description, sometimes a pattern on which the value needs to comply to, and we have some examples in here as well for most of the things. The property name itself is a prefix. So in this case, in ODS, because this is a term we will mint ourselves with an identifier. But we also have a lot of Darwin Core, of course, the TEDx standard for a lot of biodiversity information, where this indicates that this term is actually comes from, we took that term over from the Darwin Core. So this is actually one of the Darwin Core terms. We had a couple of issues still in where we had some question marks on which term to use. and we had some names and structures which we didn't really like. So we started implementing, and we came across some issues in the data model, and we identified that a new iteration of the data model was necessary to completely comply as well to the option of having a JSON LD, so JSON linked data representation of our data. So we added a lot of prefixes. We changed a couple names as well, and try to connect more with existing vocabularies, so that we got a bit more connection with the data world around us, and we also added more of the digital objects. So now all the digital objects that we create are available on Schema. And I will go into the create update tombstone event a bit later, which we completely redid. It wasn't here at first, and we completely redid it to be more in line with the W3C prof data model. What does that mean? Means that we did a lot of breaking changes in the data models. We also changed the structure. So in this case, the version number was before digital specimen, because we thought we would version the OpenDS with all its objects. We identified that it's easier if we give each object its own version number. So the version number has been moved to the back. We also had a mix of plural and singular in the URL. We made that singular as well, so that we have the same structure for all of the objects. So it's also a bit of harmonization of all the data models that we've created in the last 2 years. So be aware of that. If you're already using this or have links, they will no longer work. We created this new version for it, 0.3, and we also made the latest endpoint. And the latest endpoint will always point to the latest version of the digital specimen. So that's also easy if you want to reference it. You're not stuck with the versioned link that might change. And then here in the comment, it's indicated that this is actually version 3, and also in the identifier that this is actually version 3 of this digital specimen data model. But of course, the changing data model took some effort, but we also wanted to make a step in making it easier to look and get a feeling of the data model as a human. So this is very machine focused. So machines can easily work with this information, and we ourselves generate a lot of code based on the data models that we have here. But for humans, it's quite difficult to read this and to understand how the relationships are and how it works. So here, for example, this object has an array, a list of potentially other objects in it, which are then, we need to fix this, which are, let's see, I think this should be this, no, of potentially other objects in it. Let's see, hopefully this one works. Yeah, events. So that digital specimen first had occurrences in it. We renamed occurrences because it's such a loaded term within biodiversity data, often connected to seeing a specimen at a certain location. We changed it to event, which is a bit more generic, and this digital specimen contains multiple events. So it's quite difficult to read. We really liked the Lettermore core pages that Lettermore core created for the TEDWIC review process, and to show how the terms are structured and are together. And Ben Norton, who created these pages, already indicated that he created a generic setup. So we wanted to see if we could reuse this setup, where we have all this documentation and some resources with some diagrams, if we could reuse this setup for describing, making a human readable variant of our digital objects. But we didn't want to redo everything. So we wanted to be, that the documentation is actually based on the JSON schemas. And for GIST, we recently deployed the dev.terms.disco.tag, which you can see here. So it has the same look and feel as the Lettermore core pages, but it's completely generated based on the JSON schemas. And here for each of our objects, we currently are at 7 objects, you'll see that we have a digital specimen. And we have here information about this digital specimen. The naming convention we used, the different vocabularies from which we borrowed, namespace, prefix, and all the classes connected to this, this digital specimen. All the properties within those classes. And for all of them, for all the properties and for classes, we have this nice description of this term with the examples onto which class it belongs. And this is completely generated based on the JSON schemas. And this makes it much easier to present the data to humans so that they can easily see, okay, what properties does an event have? Okay, an event has these properties. Okay, it has assertions, and the assertion, how does it look like? Okay, the assertion looks like this and has these terms. So we're quite happy. It worked relatively easy to implement to the tool that Ben Norton created for the Latimer core. And we also created, so for the digital specimen, these they're called mermaid diagrams, where you can see the relationship. And this one contains all the different properties as well of a digital specimen. So we have a lot of properties that are available. Of course, for most specimens, they won't be all filled, but we want to have the option there. But there's also this empty relation diagram where we can quickly go over. Don't know, might still be a bit small on the screen, but where you can see that a digital specimen can have material entities, and this indicates that one digital specimen, in this case this double line, can have one or more material entities. And a material entity is basically a part of a specimen. So say we have a large rock, and on top of the rock is a mineral, but then that mineral didn't get its own registration number. We still want you to be able to describe the mineral. So the mineral is then a material entity on the digital specimen, but the material entity, so the mineral, can still have measurements and identification separate from the rock on which it sits. Digital specimen can have one or more agents, so we're still a bit in developing the agent model. It can have one or more identifiers. So let's say we have a catalog number, an occurrence ID. We might have a local identifier, and we might have a globally unique identifier. You want all those identifiers connected. But of course, the material entity, so the mineral, can also have separate identifiers as long as they're not, as long as it's not registered on a new catalog number, because if it's registered on a separate catalog number, it would be a digital specimen in itself. So that's a bit how it works. Digital specimen can have one or more entity relationships, so relationships to other resources, say Wikidata or GBIF, or I will do an example with Bolt. Can have citations, one or more, it can have one or more identifications, but these identifications can also contain one or more citations. So if the identification is a citation, we can add it as well. And identification can also have 0 or 1 taxon identifications. So this is more a specific identification based on taxonomy, mainly used for biological and paleontological specimen. But probably we're hoping that for geological specimen, we might get other types of identifications. The digital specimen can have assertions, and it can have one or more events. And these events can have a location, and that location can have a georeference or a geological context. So that's high over how the digital specimen works. So hopefully this provides an easier structure to which you can browse through our data models. Just to quickly show that we also got, the annotation model. And the annotation model, that might be best to pick the resources. So the annotation model is based on the W3C web annotations data model. I think most are familiar with this image. So the annotation has a body and a target. And you can also see that here the annotation has a body, so that's a separate object in this case, and has a target. and then a creator, generator, and can have an aggregated rating. We're still in the process of implementing this part, the aggregated rating. So this also shows how it's a bit situated, and you can also see here, we go to annotation, that we borrowed a lot from schema, from the web annotation namespace, activity streams namespace. You can see that especially things for creator, for the names, but also for the body, for the references, we make use of other namespaces as much as possible. Yeah, and then last we created a whole new object which we need to implement for the create update tombstone event. I think we shortly spoke about Prof ontology in one of our last work package 3 setup. And we thought, well, we have something which really fits the model, but isn't described in the way the model is described. So we created a new, we basically redid the data model for create update tombstone. We also renamed it. It was create update delete, but we don't delete digital objects. We tombstone digital objects. So they will always be findable. So that's why we changed the name delete to tombstone. Create update tombstone event. It's not the nicest name, but well, it's what it is. And each provenance has an entity. So what's the thing that has been changed? The activity. So the activity of it getting changed, and these are connected to an agent who does these activities. So that's also how we now structured it. So we have the create update tombstone event, and this has the activity, the entity, and the agent. And the activity indicates what the activity is, when it happened, who did the activity, so it points to the agent. And it also has an additional value called the change value, which is one we added ourselves, which contains the JSON patch annotation that we're using to indicate the changes between 2 events. So the change value will only be there if there's an update. Say a digital specimen gets new information added. This will contain the new information added, the change in the object. The entity contains the whole object, so the value will contain the whole new version of the object. And it will say this is a revision of the previous object, where it will use the identifier of the previous object. It was generated by this activity, and it was attributed to this agent. And this agent, that can either be a human or a software agent. And we store both the identifier as a name of the agent in this object. So this, we kind of try to structure it based on this Prof ontology model. Yeah, we're quite happy where we're going with this documentation. Let us know if you think anything needs changed or needs updated, or if you have other ideas on how we can better represent this information. And then it's all in line. So the JSON schemas which we have here, those are the basis for all the objects created within this terms website. Yeah, and I think one thing to mention still is that we will try to get an kind of official open review process in when we have a bit more things ready, and then we'll communicate it to the community to ask if they can provide feedback, and then we'll probably end it at the end of the summer in August or September, and then we'll try to incorporate that feedback and get a first version, a 1.0 version of all the data models out. That's what we really want before we move to the MVP. I can quickly go to some other points. We updated the miscalculation, so we got new fields in. We aligned with the triple SOM mapping that Matthias created for MIDS. I try to align with it as much as possible. I think we basically completely aligned with that calculation, so that the miscalculation done within DiSSCo is the same as made within the one that gets created by the tool Matthias created for the calculation of MIDS for GBIF dataset. We did a test run with DataSite. If you remember the previous demos, we talked about having an automated way to communicate or create the DOIs to DataSite, so it also gets indexed in their repositories. We tested the whole workflow and we minted about 1,500 test DOIs with their infrastructure, which was successful. So we're quite happy that the whole chain on that part works, which means that if we can go to production, we can start minting DOIs with DataSite. So that's a really good development. We have a linking service with Bolt, with Bolt EU, I have to say. So the European version of Bolt, the European mirror of Bolt. Let's see, I have one specimen open. So again, I'm going to do the same thing as that Sue showed. I have to log in through my ORGID. So, oh, yeah, there we go.
Sam, you have about 10 minutes left if you want to keep some time for discussion.
Yeah. Now I'm gonna try to wrap this up. But I do like to show that we now can link to Bolt EU. We will trigger this and then move on and then see the result a bit later. So we're gonna trigger the machine annotation service. We will see that we have a Bolt EU linker, and let's, for fun, do the GBIF linker, and we'll schedule these. So they should get records in here. That would be nice. Let's wait a minute, see if it starts. We did some end user testing for Discover. We're trying to harvest some user comments, some user views on how Discover and how it should work and what we can improve. And a lot of improvements in the front-end code of Discover. So Tom is working hard to get things working and extensible and maintainable so we can further build on the front-end code. What we have in draft is an RFC for a vocabulary server and for the authorization matrix. Yeah, we did some infrastructure upgrades. DOI and handle servers are now infrastructure as code. We're using Terraform for this part. And we have some project outputs in the sense that the MVP, so the milestone 14 of DiSSCo Transition Project, has been completed. So we now have a document describing what the minimum viable project of the core infrastructure will contain. And we have an updated view of the service landscape, which about to present it, I think 2 days ago in the cost session. Let's see if it got triggered. I think we might have an issue here still, so I'll have a look at it together with Tom. Let's see why it doesn't trigger. I did it this morning and it worked, so yeah, oh, there they are. Yeah, might be something else. But we can start with discussions, and then at the end I can quickly show that it has been completed and we now have a linkage to Bolt. Oh yeah, let's quickly with one slide what we're looking forward to. So as I said, the OpenES terms documentation, try to get to 0.1. Yeah, we have to implement all these code changes through the whole chain as well. So we're now proposing these changes, and then we have to modify the code so that it can actually work with the changes. Some further improve the front-end code, some documentation for supplying data and metadata. Improved handle storage. This is something that Sue is currently working on. So we have handle and DOI storage within the DiSSCo infrastructure, but we're expecting issues with the way we when we get a lot of handles, so the scalability might be an issue, and we were not quite happy how the handle storage was working, but we were requiring a change from CNRI in the handle server for this part. They have implemented the change and given us the documentation, and we'll basically guinea pig this new setup of the handle server. So that's something we will be trying in the next couple of months. We are starting talks with Naturalis for an observability stack, so we can get more feedback and quicker see and react on any issues. Uptime monitoring, improved mass support, mainly for secrets. So if you have API keys that you need to include in your deployment of the mass, we need some place for that. Tombstoning, workshop. I think it's next week, right, Wouter? Workshop of the Tethered Marketplace, which is more or less working.
Next week, Wednesday.
Next week, Wednesday, is the workshop on the Tetris Marketplace, which is one of Tom's projects in which we now use Cordura as backend and have this nice website for the Tetris Marketplace. Yeah, and a couple improvements in the vocabulary server and the registration process. So I think that's this is mainly yeah, as some backup additional resources if you want to dig further in how we set up DiSSCo. And I think we can start with discussions, and meanwhile I can, it's been completed, right, that's nice. So if we now go, I need to refresh here. We now go to entity relationships. We now see that it has two additional entity relationships. One goes to GBIF, which is a linking service that we already had. And the other one now goes to Bolt EU for the Biodiversity Genetics Europe. And we now have a link. It identified that there is the same specimen as that we have in Bolt EU, and it created a linkage to this particular specimen. And here you can find the sequence of the specimen in Bolt. So yeah, I think that's where we'll stop the demo and then have about 15 minutes for discussion.
Thanks, Sam. If you have a question, please raise your hand. No questions at all. There was one question in the chat, Sam, that I already tried to answer in the chat. That was about what a tombstone event is.
Yeah, very good. Yeah, so most systems, if you say, well, I wanted, let's say this particular specimen, I want to delete it because it was a double registration. We registered the same specimen twice, and I want to remove it from DiSSCo. Then you would completely remove the whole specimen. However, we create persistent identifiers for this specimen, and those persistent identifiers, the whole idea behind the persistent identifier is that persistent, that if you use it in your publication, that you are ensured that it will always be there. So instead of deleting all the information, we tombstone it. We say, well, this specimen was here, and this was the information that was in the specimen, but it has been deleted. It has been tombstoned. It has been archived, let's say. So that means that the identifier will keep on working, and there will be some information still in our systems, but it will no longer be active. Yeah. Chris, you have a hand.
Thanks very much, Sam, for the amazing presentation. So I have a question about the last part you showed. After recording a complex data in DiSSCo, you can then publish it to both GBIF and GeoCase. Is there Bolt systems? Is there a way after this publication to query DiSSCo and understand where this or what parts of this information were already distributed to external platforms?
Okay. Yeah, just to clarify, what we don't push, so we don't push it to a GBIF or Bolt yet. What we do is we check with Bolt if there is a specimen with the same identifier in their system. And if there is, we say, well, these two things, the specimen in our system and the specimen in Bolt system, they are the same. And we do that very rudimentarily still. We're hoping to create more complex machine annotation service, and then have several of those, so one for GBIF and one for ENA and one for Bolt, and then yeah, you can think of a couple others where specimen data is being used, and we also want to get that connection to that specimen data. Yeah.
Sorry, so then a follow-up. So once this check is done, by looking in DiSSCo, so by taking data from DiSSCo API, would I be technically able to understand that that these links are checked and existing, or so is there a representation of this check? That's my question.
Yeah. So once we identify the positive relation, we create the annotation object, which I showed, and the annotation object has information about the machine the piece of software that identified this relation, so the machine annotation service, when this was identified, so the moment that we identified the relationship, and then the full relationship as well, including the identifier and a resolvable URL if you want to click on it. And that's based on the W3C web annotation model. And we try to encompass all the information that you need so that you can always go back and see what is the software, what version was it, and then preferably if it's open source, you can see in GitHub what the software was and how it was being used. So that's always traceable. And if you download the specimen information, you will see that there is an annotation describing this relationship and when it happened, and we'll identify it. Yeah.
So by using the API, you can find both the relationship as well as the provenance information about who created that relationship and based on what.
Thank you very much.
Isabel.
Yeah, I was wondering with the mass annotation services, for example, for georeferencing. So the way you demonstrated it, it looked like then there was a georeference that you could then check as okay for a specimen, and then it would go into the system. So there would be a human eye on saying yes, it's not just mass updating specimens in the system, right?
No. So what the mass does is it creates an annotation.
Yes.
Then before it gets into the actual digital specimen information, it still needs to have a check, preferably by a person.
Yeah.
But it could also be, as if we're generating thousands and thousands of it might be too much for humans, so that we might need some score. And if it's we think that it's really a high score, it's really positive that this is correct information, we might get some automated process of getting it in. But the idea is that humans can always check the annotation before it gets merged into the actual digital specimen information. Yeah.
So a bulk check okay would be nice. Yeah. But I was then wondering, when you have that in the DiSSCo system, is this information then also able to be channeled down into the original system, for example, specify? So if I have one specimen that has a lat long for this gets annotated, I say yes in the DiSSCo system, then will that be pushed back to the affected records so that collection managers can see it locally?
Yeah, that's a good question. Yeah, ideally that's what we're aiming for. So we have already did a session with a collection management system providers, and they're really interested in working with us together to implement that feature. It will not be part of the first, let's say, the minimum viable product, but that's definitely something we want to work on in the next steps of DiSSCo, to really round trip that information, to get it from the collection management systems into DiSSCo, have it community curated, add information to it, add annotations to it, and then get it back to the collection management systems. Yeah, that round trip is definitely on a roadmap.
Yeah, that sounds good. Also, if so there are many Specify installations that already now sort of publish their data to GBIF so directly. I guess they will keep doing that also, or how do you envision that?
Yeah, they might. So there could be two options. They could either say, well, we provide our data to DiSSCo ourselves, or you could say, well, I want to publish my data through DiSSCo. So I want it first to go in DiSSCo, and then DiSSCo people can update it and start working with it, and then automatically push it to GBIF. Yeah, so it might be that we get two options. Ideally, we would like to get things from DiSSCo, because there you have an option to together work on specimen and curating it and extending that information. So getting more and more information into the digital specimen. And then pushing it to GBIF so that hopefully the quality is as high as possible. But the other route, it won't be closed. So it will still be possible for institutions to go directly to publish the data directly to GBIF. Yeah.
Okay, thank you very much.
Okay, Dagmar, and then there are a few questions in the chats.
Okay. Yes, I have quite the same question as Isabel. How would you realize the loop back to the collection management systems? Because perhaps they have unpublished specimens with similar information which they would enrich internally. Perhaps it would be an idea to have an kind of API in a fixed scheme where the major collections management system like Specify or Diversity Workbench could program against this.
Yes. Yeah.
And yeah.
Yeah. No, we're already. So the platform already provides those APIs. So for each specimen, there's an API endpoint where you can get all the information from the specimen and also all the annotations. So that's already there. But what we would ideally use is a kind of event-based setup, in which if DiSSCo makes a change, we would publish, we would push that change to the collection management system. And if the collection management system makes a change, it would push it to DiSSCo. So now if we want to check if anything changed in the underlying system, in the collection management system, we would have to, we need to grab the whole DiSSCo archive, go through everything, see what is changed with the information we have, and then say for this particular specimen, maybe 1 out of 1,000,000 of that specimen, we need to do an update. So that's a lot of compute. It's quite a task to go over all those things. Ideally, we would like to have that the collection management system, when there's a change or a new specimen has been added, it would push the change to us, and we would store only that change, and so we don't have to check all the millions that don't change. And we actually in DiSSCo Prepare wrote a deliverable on it. I will put it in the chat here, by Volker Glukler and Julia Pimreis, and yeah, we were included as well on how to set up this kind of event-based data exchange structure with the collection management systems. Yeah, so we think it would massively reduce the amount of data that unnecessarily gets processed and also gets pumped over the internet, gets moved over the internet. Yeah. So we have a couple plans there, but we still need to, work through them step by step. Yeah. I think we have a couple minutes for questions in the chat.
There was one from Frank about how to link a digital specimen to its collection in the hosting institution. And do we link to other schema data model APIs like DiSSCo?
Yeah, that's a good question. We have looked at creating this kind of linking service for DiSSCo, but we identified that it's still very hard to connect a digital specimen to collections, as the collection identifiers are often not included in the specimen information. So this is, I think, an issue that's a lot broader. We're also trying to discuss this with DiSSCo as well, to see if we can make a recommendation on how to include the collection identifier in your digital specimen. And if that identifier is there, then it would be easy for us to connect to DiSSCo. Yeah, I hope that covers the question a bit. Frank,
yes,
yeah, okay. Yeah. So that the main issue is that the information to link it is just not yet there. And that's we're more or less the same with ENA and with BOLD, that it's there it's often that we have the identifier in our data, but ENA and BOLD doesn't have the identifier of the specimen in their data. so that it's still really hard to link these two together. And that's of course where also DOIs comes in. If we have this digital object identifier, which is persistent, it can be used in all infrastructures, and then we can link all the things together through that DOI. Yeah.
I have a quick question. Is it possible to have a generic field for a kind of foreign key to a repository of collection without specifying the type of repository for the collections? See?
Yeah, so and then yeah, get a foreign key in the digital specimen which points to the collection yes. Identifier, right?
Without telling if it will be GRCycle or GBIF or other repository.
Yeah, no, that would definitely be possible. Often at the moment, the collection ID is now, let's say, an abbreviation of the collection. I know, for example, in Naturalis, we have MOL, and that just stands for the molecular collection. But that MOL is being used by, I think, 4 or 5 other institutions as well as collection codes. So we cannot unambiguously connect it to another collection yet. But if we, for example, I think in the is it milestone 13 of DiSSCo Transition Project, we made a recommendation to include the GRCycle identifier as collection identifier in the digital specimen. So we did make a recommendation there.
Okay, thank you.
Okay, there's one more question from Matthias. Are there persistent URIs for the custom terms in the OpenDS namespace?
Yeah, good question. Not yet. No, and yeah, the name and Sharif is at this moment working on seeing if we can do it another way with fair digital objects. So then the term would get a DOI or a handle, and that would point to the information of the term. But yeah, the rs.dissco.eu is not yet resolvable. That's still something to fix. Yeah. And it might still change to a DOI or handle. Yeah.
Okay, our time is up. The next demo session will be the 28th of August. This is again on a Wednesday at 11 o'clock. So if you're interested, mark down the time in your agenda. And we will distribute the Zoom link for that soon. Thanks everybody for joining the session. And yeah, if you have any further questions, you can just mail us. Thank you.